Hi, I'm Lily. I'm a workshop leader for Art Technically, which is a nonprofit based in Memphis, Tennessee, that promotes STEM and arts education for K through 12 students by providing free STEM and arts programming like this. I'm also a PhD student here at Rensselaer Polytechnic Institute, working at the Center for Lighting-Enabled Systems and Applications. Before coming to RPI, I worked as a software developer or programmer for the District of Columbia's Space Grant Consortium in Washington, D.C. While working for DC's NASA Space Grant Program, I met an astrobotanist, which is a scientist that studies growing plants in space, and he inspired me to go to graduate school to study plants. So this top left photo here is from 2019. It's from the last in-person NASA Space Grant Conference in Washington, D.C. before the pandemic hit. I'm pictured here with a couple other scientists that worked for the DC Space Grant Consortium at the time. At the top right over here, you'll see a photo of me from graduation last year. I graduated with a master's in lighting. I specifically looked at how plants interact with light, and that's what I research now. And the bottom photo is me in another lighting lab. And that bottom right one with the purple light, that is from my last in-person Astrobotany workshop. I'm very sorry I can't be there with you all in person, but hopefully with your activity kits, we'll be able to emulate that experience as best we can. So here at LISA, I study Controlled Environment Agriculture, or CEA. CEA is a method of growing food inside. When we grow food outside, like in fields, we can't control how much light the plants are getting, how much rain the plants are getting, or what the temperature is outside. So when we grow food indoors, we can control the plant's environment a little bit more. The three main ways we might control a plant's growing environment are where we grow the plant, such as what kind of soil the plant is grown in, the climate, which might include the temperature and the amount of water the plant gets. We're counting it from rain. And the lighting, which may include the sun or electric grow lights. There's a wide range of agriculture and controlled environment agriculture depending on how much we want to control the plant's growing environment and what in the environment we want to control. Many edible plants grow without any human intervention. For example, if you were to find a wild blueberry bush in the forest, that blueberry plant grew without any humans controlling its environment. But instead of gathering food from a forest, farming is a much more efficient way to grow a lot of food to feed our communities. Traditional or field farming is where most of our plant foods come from nowadays. On a traditional farm, you can control more of the plant's environment than you would in the wild, such as where the plants grow and how much of the plants grow, or how much you plant. Traditional farms are very common, so you've probably seen one or even maybe been to one. But if we want to control our plant's environment even more, we may choose to grow our plants in a greenhouse. A greenhouse is a glass or plastic building that can protect plants from colder weather. A greenhouse allows sunlight to reach the plants while protecting them from cold weather, rain and snow, and sometimes pests like animals and bugs. You may have also seen a greenhouse before, especially if you live somewhere that has cold seasons. If we want to control our plant's environment even more, we may choose to grow our plants completely inside in something called a vertical farm. A vertical farm is a building where plants are grown in stacks on vertical shelves in a completely controlled environment. The lighting, temperature, water, and more are all controlled by scientists in a vertical farm. Because the lighting, heating, and AC, and water, transportation all requires energy, vertical farms are very expensive to run. But some vertical farms can produce foods like tomatoes and lettuce, tastier, quicker, and more nutritious than traditional field farming. And in some places where it gets really cold or really dry, traditional field farming may not be possible in the cold or dry season. The lab I work in at RPI is focused on researching controlled environment agriculture for vertical farms. So here's a quick tour of our plant lab here at RPI's LISA Center. So here is our plant lab at RPI's LISA Center. This is our main area where we take measurements and analyze all of the plants that we grow. Back here is a dark room where you can see we're doing a grow light experiment over there. We also can take measurements of different light bulbs and lighting systems, and this equipment over here, that's an integrating sphere where you can put a light bulb in and measure how much light it gives out and what the kind of colors are. This is one of our recent grow light experiments. We've built this and now we're testing to see how the LEDs or the lights are performing. You'll notice that it's purple grow light, which is the kind that is in your activity kit. That sensor right there is measuring the lights above, and if you look all the way up, you'll see all of those LEDs shining down into this testing growth chamber. But I'll cover it back up so it can continue testing. And then we're going to walk over, here are our offices for Lisa. And on the other side of our floor that we have at RPI, we have our growth chamber lab. This is where we grow all of our plants. Those big freezer looking things are all of our different growth chambers. This one has sort of a greenish looking light on it. You'll see that there's another sensor there testing those lights and some tomatoes that we're just storing up top. Here's another growth chamber. These are some pretty mature tomatoes that are growing under those LEDs. And then the next one is some more tomato plants we're growing. These are a little bit younger, so they haven't had any fruit yet, but I'll close that chamber up again so they can continue. This is the batch that we're going to be doing our measurements and analysis today. You'll notice that they are growing in water, not soil. There's no soil in our growth chambers at all. That's called hydroponics, and we'll talk about it a little bit later. Here's some little sprouts that are also growing in water, so you can see that. And here we have one of our lab techs is taking out these measurement sensors so that we can take all of the tomato plants out and do our measurements. We're going to drain all the water out so you don't have to carry the heavy water around. And here he's taking some chlorophyll measurements with that little machine right there. That little clamp measures how much chlorophyll is in the leaves. We'll take some photos of the tomato plants against this black backdrop just for record keeping sake, and then wheel them all the way over to that measurement lab I showed you earlier. And now the lab tech's going to prep to take our analysis and measurements of the plants, starting with some liquid nitrogen that we'll use to freeze the plants later. He'll take some different measurements on different machines we have, weigh all of the different parts of the plants, and then when he's done, he'll dip them in the liquid nitrogen to freeze them and store them in the freezer for record keeping sake. We hope you enjoyed the quick tour of our lab. There is one more scenario that is even more controlled than a vertical farm. That is astrobotany, or growing plants in space. When astronauts grow food on the International Space Station, or maybe one day on another planet like Mars, the food's growing environment has to be carefully and precisely controlled. Today, we're going to learn about astrobotany. Unfortunately, I can't be with you in person today, but our workshop leaders, Kate and Grace, can help answer any questions you have. And if you have any questions for me, you can have your parents help you email lily@arttechnically.org. If you haven't already, make sure to open your activity box. In it, you will find a copy of Leland Melvin's memoir called Chasing Space, an astronaut ice cream packet that we'll talk about later, some leaves and a light bulb that we'll use for a hands-on experiment, some stickers, and a paper packet with the title Astrobotany that you can use to follow along during our lesson. The only thing you'll need from your home is a standard lamp that you can put that light bulb into. The light bulb will fit into any standard household lamp, but make sure that you have an adult help you get the lamp and help you put the light bulb into it when we get to the experiment. You can open up your packet to page 6 and follow along with the next video.